Good morning, everyone. In this session, I want to discuss the implementation of K nearest neighbor. Already theory part we have completed. So now let us build a model using this KNN. For that, here I am using a data set called as iris data set. So first I want to discuss about this data set. So here, this is the data set where we have four features of sepal length, sepal width, petal length and petal width. And as per this, it belongs to, there are three species are there. Three means here we have three classes. One is Iris setosa, versicolor and Iris virginica. And as per the sepal, these features, whether it belongs to which species, that is what the description of this data set. So with this data set, now let us implement this KNN algorithm. Very first step, we know that we have to import the packages pandas, numpy, and from sklearn, training, testing, splitting, and standard scalar. And from sklearn.neighbors, here we are importing the k nearest neighbors. And then next one is evaluation. We are going to import the confusion matrix, F1 score, or simply if accuracy score or confusion matrix or metrics, we will get all these evaluation metrics. And here for this also I'm using the Google Colab. So from Google Colab, I'm importing file, and that file name is iris.csv, and that I am storing it in a variable called as this dataset with the help of a function called as pd.readscsv. I'm uploading the dataset. Then I want to print the head of the dataset and length of the dataset. So see here, the head represents the 5 rows here, the first 5 rows, and the length of the dataset is 150. So here, then I'm printing the dataset information. So total we have total 150 entries. There is 6 columns. 0 to 5, this is features, and the last one is a class label, the species. And then the next one is I'm splitting the data set. For that, I have I'm extracting the independent and dependent variable. For that, for the first one, I have extracted 0:5, that is 0 to, so 0 to 4th it is going to display, which is not going to include 5th. And in y variable, I'm storing the 5th value, that is species. And next I'm training and testing. Here, test size same 30% I have given. I am calling these two variables x and y. Next, I'm scaling the data, feature scaling to normalize the data. So created a standard scalar. And for training, we have to fit and transform. And whereas coming to the test data, directly we can transform with the help of the standard scalar. That is the pre-processing step. Till here, these are the pre-processing step. Now here, the important part in KNN is we already discussed in theory part. Whenever we are implementing the KNN, the very important parameter is that choosing the value of k. So already told you we have to take the square root of n as the value of k, and it should be odd. It should be odd value, and it should be square root of n. N is nothing but the length of the data set. So the same thing I have here used here. So y test we already defined in testing data. So that length of test set, I'm just printing the length of y test, and for that I'm using the square root. For that we require math function. That's why I have imported math function here, and I'm storing it in a variable called as k. So k equal to math dot square root of the length of this test data set. Okay, and then the next one is, already one more condition is here we should have odd number. So I'm rounding up to nearest odd number. For that I have used again from maths ceil function of this the resultant k, and we have to ensure that always the k should be odd. For that I have written here a piece of code that k percentile 2 is equal to 0 and k equal to k plus 1. Okay, for getting the odd value. Why? Because we have, this is the condition of a k nearest neighbor, that always we choose a k value of odd number only. Then I am printing the k value. And after this calculation, as per the length of our test data, we got k value as 11. Okay. And next one is, it's time to build the KNN. For that, I have created an object classifier. From that, I have created k neighbors classifier. This is the k nearest neighbors. And here I am taking n neighbors. We have here 3 attributes, n neighbors. That means the classifier will consider the 11 nearest neighbor from a given data point. And p equal to 2 says that it is going to use the Euclidean distance. This distance is equivalent to the Euclidean distance. And we know that default, we are going to use the metric called as the Euclidean distance. That is what here I have given. So these 3 attributes are important whenever we are building the k nearest neighbor model. Then next one is fitting the model. For that, the classifier.fit, we are fitting the X train and the Y train. And then it's time to predict the test set results. Okay, for that, the classifier dot predict a function of test data. And this is the predicted data. So you can see Virginica, versicolor, set of 3 different class labels. Okay, this is the predicted data. And now it's time to evaluate the model. For that, from MP.array, I am printing the confusion matrix of test data and the predicted data and printing that confusion matrix, which are stored in a variable CM. So see, this is the true positives. Okay, 16, 8, 11, as it is a multi-class classifier. Why? Because we have more than 2 labels. So this is a confusion matrix for multi-class classifier. And next one, I want to print the accuracy score of this test data and predicted data. Yes, I got 100% result, that is 1.0, which may leads to the overfitting of the data. We should be consider this. Okay, we should take into account of this. And now next, I want to visualize this confusion matrix. Now visualization of confusion matrix I require. For that, here what I am using is, we know that matplotlib, and here I am with the help of cban. This is one way to visualization package. So I am importing the cban as SNS. Now we know this from sklearn.matrix, we are importing the confusion matrix. Now for confusion matrix of test and predicted data, and printing confusion matrix. Now again here I am defining the class labels. I already told you in dataset we have 3 different class labels, that is Virginica, versicolor and setosa. So the 3 labels I have given. Why? Because I want to print it in a confusion matrix of these 3. That's why I have given here, defined the class labels. And then plotting the confusion matrix. For that I am using PLT, which is from the matplotlib. Figure of size 8/6. And as I am using this cban, so whenever we are using cban, we are representing it with the help of another visualization package method called as heat map of this CM. And here it has some attributes of annotation true, FMT equal to D, that is the dimensions, and CMap blues. I want to print this in blue color, and C bar equal to false. And here X label I want predicted labels, and Y column I want true labels. I want title it as confusion matrix. And here X ticks and Y ticks, whenever we are using heat map, now we are going to use this X ticks and Y ticks. There is no other option. Whenever we are visualizing a confusion matrix, we have to maintain a one cheat sheet where we have to remember all these labels, all these piece of code of X ticks and Y ticks. Then I'm just I want to display the confusion matrix. For that I am using this plot.show. So when these X ticks and Y ticks are required when we use heat map. Okay, that is cban. Otherwise, if you use normal confusion matrix, we don't require these 2 pieces of codes. In earlier example for decision tree, even in that way also you can visualize the confusion matrix. This is another way to visualize a matrix with the help of cban. For that reason, I'm showing you this piece of code. So this is the original confusion matrix, and the visualization of confusion matrix is something like this. You can see here. So as it is a multi-class classifier, see here. So confusion matrix, I have defined the class labels. These are the labels, and here these are true labels, and these are the predicted labels. In this way, we can visualize the confusion matrix. And the last one is about the classification report. We know that from sklearn.matrix, we are going to print this classification report of test data and predicted data. Here, for each class, what is the precision, recall, and inference code? We almost reached to the 100% accuracy of each and everything. So this is how we are going to implement the KNN model for this particular given data set. Thank you.